Hello everyone, today we're going to introduce the OpenAI's reasoning model, and also we will see that how we can use that one in data analysis and also compare the performance against the traditional GPT model. So reasoning model has been a very hot topic recently. OpenAI and also DeepSeek all have their own reasoning models. So generally speaking, for OpenAI's reasoning model, so the model will take multiple steps to process the prompt before they generating responses. So they will take multiple iterations, and during those thinking process, they are going to compare the different solutions, and hopefully they are going to give us the best or better solution. So that's better than the traditional GPT models. And also, the model is using what they call the reasoning tokens to help the model to find the better solution. So for example, when the model receive a prompt, so it will take the input. They will also generate reasoning tokens to help compare or identify different solutions. And they may have an initial output, and then they will go to the second iteration and also go to third iteration until they reach the limitation of the context window, and then they response. So in their response, they will report the output. Keep in mind that the reasoning tokens will not be reported. This is different from the DeepSeek R1 model. So if I'm using DeepSeek, you will see the reasoning process. However, if you are using the OpenAI's O1 model, O1 reasoning model, we will not be able to see the reasoning process. So the key difference between reasoning model and also GPT. So for reasoning model, it is a multi-step reasoning approach. So it will evaluate different solutions before they reporting the best response. It is optimized for complicated like data analysis, coding, and also planning. And also it also has great capabilities in understanding data visualization. So if you have a charts and the reasoning model is doing better than the GPT models. The reasoning model has a new parameter called a reasoning effect. So it controls that to what level that to adjust the depth of the reasoning. So it has low, medium, and also high. So three options. And also if you choose high, it will take longer, and also it will of course it will cost more reasoning tokens. So let's start. So first you need to buy OpenAI API. So from OpenAI website, and then we recommend that you store the API in a secret place, in a safe place. So in our case, we are using the AWS Secrets Manager because we are using the AWS SageMaker to host this notebook. And if you haven't already done that, so you also need to pip install the Python library. The one that we need to install on this instance is called OpenAI. So let's just go ahead install that Python library. So OpenAI library will allow us to call the O1 models and also the GPT models. In addition to OpenAI, we also need the following libraries like Bottle3 to call the AWS Secrets Manager. We also need to translate some data into JSON, so we need JSON Python library. We also need IPython display and pandas and pprint. All right, so let's import those Python library. And the next, we're going to retrieve our API. So I already stored my OpenAI API on my AWS Secrets Manager. So this is where I need to call this AWS Secret Manager function to get my API key. So I just call this function. So I just define this function. And next, so I will call this function to retrieve my API key, and then I'm going to pass that one to this OpenAI client. Okay, next. So today we're going to try and use the reasoning model to do two tasks. The number one is to understand or to analyze a data. So the dataset we used is called the diamonds dataset. So it's diamonds.csv file. So it's not a big dataset. You can find this dataset on my GitHub. The data contains some attributes about some diamonds, like their weight, color, clarity, and also price. So let's go ahead, import load this data. So again, you can find this diamonds CSV file from my GitHub. So it has weight, color, clarity. It also has several raters, so the price are provided, evaluated by those raters. So one thing that is very interesting is that diamonds have a clarity called IF. So IF is the highest level of the clarity of the diamond, and normally it should be the most expensive diamond. And however, in our dataset, if you calculate the average price per clarity, surprisingly, you will find that the diamonds with the IF clarity tend to be the least expensive. So that's very interesting. And if you use like some BI tools like Tableau to explore the data with human being, you will be able to see that the reason is because that in this dataset, the diamonds with RF clarities are actually smaller. Okay, so it's smaller, so that's why they have the lower average price. Okay, so that's the dataset that we have. And now we are going to see that if the reasoning model is able to find this pattern and also is able to give us a reasonable explanation. So here we are going to write this prompt. So we tell the model that to analyze the provided data and determine that why diamonds with RF clarity have the lowest price. We also want the model to provide some Python code so that the code can generate charts to support their analysis. And in the prompt, we also pass the data, so in a JSON format. So we can see that we loaded data into pandas. We pass the data into this JSON format. Okay, so let's define this prompt. All right. So first, we will start with a GPT model. So we defined a GPT help function. It will receive the user prompt. We will provide the prompt as a user message. And here we're using a GPT 4.0, so that's the most powerful GPT model as of today. We also will set the temperature to be 0. We also want to see the token usage, so we'll see that how many tokens being used. Let's define that function. So now we're going to get a result from this GPT model. Okay, so let's see whether or not the GPT model is able to answer the question, so why the IF diamonds are cheaper. Okay, so first we can see that the total token 11,000. So the prompt token, and you can see that there is no reasoning token because the GPT model is not a reasoning model, so it didn't use any reasoning tokens. And next, we're going to display the result. Because for GPT models, the results are in markdown syntax, so we are using this display markdown function to show the output. Okay, so you can see this is the output from the GPT model. So to analyze IF, why they have the lowest average price, we need to examine the dataset and consider different factors such as weight, rating. So it suggests that start loading data into pandas, and now they are going to filter data based on the clarity, and they will calculate the average price for the IF clarity. They will they also need to calculate average price for the all other clarities. I guess they're going to make some comparisons. So they also create some charts, average price by clarity, distribution of the weight for the RF clarity, distribution of the colors for RF clarity, and also do those following analysis. So it will create bar chart, histogram, the count plot for colors, the count plot for raters, and it has those conclusions. So the weight. So if the are lighter, then it could explain the lower price, since weight significantly impact the diamond's pricing. So, and also color and also rater. So based on this output, it's more like some suggestions. So they just gave us a Python code that, okay, so if you run those code and you then human can read the charts and also be able to understand why RF diamonds are cheaper. So let's run those code and let's see if we how their data look like. So I'm going to copy the generated Python code. So start a new cell and paste. I'm going to remove those parts because we already have the data that being loaded. Okay, and now if we run this piece of Python code, and so we should be able to see those visualizations. However, we can tell that GPT model didn't answer the question. They just provided some possible solutions to investigate this problem, but it didn't give us a real answer for our question. So let's look. So they did great, gave us some nice chart by providing the Python code like average price by clarity. We can see RF indeed is lower than the other clarities. They also gave us a distribution of the IF weight distribution of the diamonds, which to me does not make any sense because if you only see the IF, well, it may make a little bit of sense because we can see most of diamonds are smaller, so that's actually the reason. But GPT model didn't spell that out, didn't tell me, okay, that's exact reason. Color distributions, okay, so we can see for RF, so we can see that the colors and also raters. Again, this just gave us some possible solutions, but it didn't give us a conclusion in our to our question. All right. So now we are going to move ahead with our reasoning model. So similarly, we are going to define a help function. So with O series model or reasoning model. In this model, as we mentioned earlier, so it has reasoning effect. So you can control the reasoning depth. So we are going to use high. In reasoning model, the temperature parameter is no longer supported. So you cannot change the temperature. And also in reasoning model, the system message is now replaced by the developer message. So if you want to provide some instructions to the model, like as a system message, you should call it a developer. Here are some best practice for the O1 models, and those are from the OpenAI reasoning models best practice guide. So for example, we need to keep the prompt simple and direct. And also, this is different from a GPT model. So for the reasoning model, we should avoid the chain of the source prompts because O1 model already did that one internally. So we no longer need to provide those instructions. So that's a huge difference between the GPT model. So in GPT model, we mentioned that we should want to provide some chain of the source to give more direct or clear instructions for the GPT model. But for O1, we should avoid chain of the source prompting. We still need to use delimiters like markdowns, XML tags, etc. And also we should try some zero shots first, and if necessary, we can give them some examples. And also keep in mind that the markdown syntax is disabled by default. So that's also a difference between O1 and the GPT, between GPT model and O1. In GPT model, the default output format is markdown syntax, is markdown. However, in O1, it is disabled. So we'll see that later. All right, so this is the function. So you can see here, we're using O1. For the reasoning effect, we're using high. We no longer need to provide temperature. And also, we still also want to report the token. So let's define this function. For the prompt, we're going to use the same prompt. So the prompt that we defined earlier. So let's look at the prompt. So the prompt is that analyze the provide data and also explain that why IF diamonds have the lowest average price. Provide Python generate chart to support your conclusion. We also provided the data in the JSON document. And now let's try this O1 model. And hopefully O1 will be able to answer our questions. And we will also see that how many tokens are used in O1 model, especially the reasoning tokens. Okay, so it definitely takes longer than the GPT model. We can see that the prompt token is almost the same. However, we spend more tokens in the reasoning process. So here you can see the reasoning token is 2000. So definitely it's O1 model is more expensive than the GPT models and also slower. Okay, so let's look at the output. So this is output. So again, you can see that the output is no longer markdown syntax. So this below is the step-by-step Python analysis showing that the main reason the IF diamonds with a lower average price. Okay, so so it says that clarity alone does not dominate the final price. However, it has the weight, so the price per character, and also colors have much larger impact on the total price. And it gave us conclusion. So because a lot of those IF diamonds in the dataset happen to be smaller diamonds and also usually end 0.3, and their average total price is much lower. Okay, so that's very nice. They also provided the Python code, so we can load data and we can calculate average price per clarity. So instead of choosing the diamonds that is only IF, so they calculate the average price per clarity, and they gave us a bar chart. So this bar chart shows that IF has the lowest average price, despite it is the top clarity. And also why IF can be cheaper. So to see why, look at how many IF diamonds are in this dataset are small. So they count the diamonds by clarity and also average weight, and they report the result. And also see that many IF diamonds is small, so 0.2 or less, smaller. And also they also give us another chart that average weight by clarity. And this chart shows that IF diamonds tend to be smaller on average, which keeps their lower price lower. So they have this conclusion. So the dataset has many smaller diamonds, making them price lower. And the larger diamonds, like with VS or VVS clarity, often cost far more in total. And so that's why that RF, although it's normally it's a high clarity grade, but average price is lower than the other diamonds. I think this analysis is very nice. So it's almost the same as human beings or data analyst who analyze the data set will go through the same process. Let's also look at the Python code. So again, I'm going to copy the code that the O1 model provided. I'm going to paste. And in the code, I'm going to remove some part of the Python code because we already have the data loaded in the data frame. I also need to delete some non-Python code. So okay, so let's run that code. So we can see that the average price by clarity, we can see IF indeed has the lowest average price. And then we see the weight, average weight by clarity. We can see that IF has the lowest weight. Okay, so that kind of makes sense. So can explain that why IF are cheaper because they are smaller diamonds. Okay, so I think in this example that O1 model does better than the GPT model. So it is able to give me a very correct answer that why the IF diamonds are smaller. So next, we're going to try another example. And in this example, we are going to download an image from the internet. And then we're going to let O1 model and also GPT model to analyze this image. So it's a chart and see what is the problem of this chart. So the data I selected is a very popular image that is this line chart. And this line chart is misleading because it looks like that the number going up, but actually if you look at the y-axis, you can see that they put 0 on top and also 1000 at the bottom. So actually the number dropped. So from 800 to 700, so the number actually dropped. But because they kind of flipped over the y-axis, so the chart is kind of misleading. Okay, so I kind of choose this chart randomly. So feel free to use a different image if you are interested, and feel free to replace that image URL here. All right. So next, we're going to define our prompt for this image analysis. So in this prompt, so we can see that first we have text prompt, and we just ask what's wrong with this image. And then we provide our second content, our second message, where the type is the image URL. So, and then we provide where the image is from in the internet. So that's an image URL variable, which you can see we define here. All right, so that is our prompt. So first, we're going to try to use the GPT model, so the GPT help function that we predefined, and to analyze this image. And you can see here the prompt token 800 and the total token is 900. So it used 0 reasoning tokens. Let's look at the analysis. So the image has a misleading y-axis, which is accurate, but the next said that the axis start at 600 instead of 0. Which exaggerates the visual difference in the number of gun deaths over time. This can make the changes appear more dramatic than the actual are. All right, so I guess actually the conclusion, the result is not totally accurate. So it has misleading y-axis. Yes, the reason is that they start from the maximum number, go up to the minimum number. So that is the reason. So that is the misleading part. So a GPT model didn't give us a 100 accurate response. So now let's try to use the O1 model. So we are using the O1 O series help function that we defined earlier. We also see that how many reasoning tokens are used in this analysis. Okay, we can see that the total token is almost more than twice as the GPT model. So we can see that the prompt token is even smaller than the GPT model, but it span like 1,000 more than 1,000 reasoning tokens. So reasoning model is more expensive than GPT models. Let's look at the result. Okay, so we can see that the result is accurate. So the major problem is that the y-axis is essentially upside down with 0 at the top and larger value at the bottom. Okay, so this makes the visual appear misleading since high numbers are plopped lower other than the high numbers that we would normally expect. Okay, I think O1 did a great job in analyzing the images as well.